Alright, so in this video we're looking at the SEC 2016 Leaving Cert Higher Level Maths Paper 2 question 4. The question asks, the diagram shows a semicircle standing on a diameter AC. So I know this is a diameter and BD is perpendicular and this is perpendicular here. Prove that the triangles ABD and DBC are similar. And remember, what does similar mean? It means that their corresponding angles are equal. Okay, so what we're trying to show is, well, hold on a minute. I know that the angle ABD is equal to 90 degrees, given. And I know that the angle DBC is equal to 90 degrees. And we know that because it is a compound angle. As in, they add up to 180 degrees, both of these. So this one has to be 90 degrees right here. Brilliant. Okay. So now I need to show that this angle here is equal to this angle and this angle here is equal to this angle. That's the next two things that we really need to do. We know that the angle ADC, is equal to 90 degrees, as all angles standing in an arc of a semicircle are 90 degrees. Think about it, they have to be half of the angle at the center. The angle at the center is 90 degrees or 180 degrees. So these angles here, this angle has to be 90 degrees. So what we're going to actually do is show that the yellow triangle is similar to the green triangle. Okay. Then I'm going to show that the purple triangle is similar to the green triangle. So if yellow is similar to green and purple is similar to green, then yellow must be similar to purple. So let's go and say the angle, let's label them 1. No, I won't label them 1. The angle DAB is similar, or is common, to triangle ADC and triangle ADB. The angle ADC is equal to the angle ABD. They're equal to 90 degrees. And the third angle are equal. Therefore, triangle ABD is similar to triangle ADC. So that's the green one and that's the yellow one. I'm going to continue and go the angle DCB is common, it's in both, to triangle DBC and triangle ADC. The angle, measure of the angle ADC is equal to the angle DBC. They're both equal to 90 degrees. Third angle are equal. Therefore, triangle DBC is similar to triangle DCA. That's the green one, isn't it? DCA, or yeah, that's the purple one. Therefore, the triangle ABD is similar to triangle DBC. Next question. If AB is equal to X, AB is equal to X, and BC is equal to 1, and BD is equal to Y, BD is equal to Y, write Y in terms of X. Okay, so it might be useful to actually label the angles that we know that are equal. Those two have to be equal. 90 degrees, 90 degrees, and these two have to be equal. And I always find it useful to just draw out the triangles again that I deal with. So, fine with the green. What am I going? A, B, D. Blue. And going X, Y. And the other one now is a little bit more careful. Green, red, blue, and I'm going C. B is at the red, D is at the other one. BD is Y, BC is 1, and I want to write Y in terms of X. So Y is equal to something with X's. I know that X over Y, this over this is going to be equal to this over this is going to be equal to Y over 1. So X is equal to Y squared. Y is going to be the square root of X. So if you go back and look at A, imagine this length was X here. And if you were to extend it 1 centimeter, and call this 1 centimeter. I'm actually going to color it a different color. 1 centimeter. 1 centimeter. Then we could bisect this distance from T down to here by using our compass. So remember, what that looks like is you're going to swing an arc just so it's greater than halfway, and another arc just so the radius is greater than halfway. And we get a perpendicular, so it's here, that's the bisector. And draw a circle then with the center that is TU. The center is there, such that the circle goes through. Now, obviously I'm doing a bit of a sketch. There, look, close enough. The circle goes through, or has the midpoint here, or its center there. This should look really like the semicircle that was given at the start of the question. I know I want to get something that is the square root of X long. Well, from the previous part of the question, that was Y. I want to find where Y is. We'll go back to part A, and it points out that if you draw a perpendicular straight up here, this green length is Y, which is equal to square root of X. So then we're really saying this green length, remember I've said X is TU long, that's X here. So this green length is really the square root of TU long. A little bit of a weird question, to be honest. I don't think it was well answered. So much so that you got 15 marks for A part 1, only 5 marks for A part 2. And then only 5 marks for the last part as well. So they really front loaded it because it wasn't well answered. And as I said, yeah, it is absolutely a bit of a strange question. Hopefully you found the video useful anyways.